All right, what about if we have more than one acid in our mixture? So generally, you can ignore the contribution of the weaker acid. If you have a mix of a strong acid and a weak acid, your ionization of the strong acid is going to give you a whole bunch of H3O+, so it's going to shift the weak acid's equilibrium to the left so that any added H3O+ from the weak acid is negligible. If you have a mixture of weak acids, as long as one is significantly stronger than the other and they're at about the same concentration, you only need to consider the stronger acid. So let's look at an example. If we have a mixture of these three acids, okay, so these two acids in water, find the pH of a mixture of 0.150 molar hydrofluoric acid and a 0.1 molar chlorous acid mixture. So if we compare these two acids, we see that the Ka for hydrofluoric acid is 3.5 times 10 to the minus 4. The Ka for chlorous acid is 2.9 times 10 to the minus 8th. Plus, our concentration of chlorous acid is lower than that of hydrofluoric. So for this mixture, we can ignore our chlorous acid. We can ignore our water equilibrium like we've been doing and just focus on our hydrofluoric acid. So for our table, we have hydrofluoric, we have F- and H3O+. We're starting with 0.150, 0, and 0. We lose some, gain some. So at equilibrium, we're going to use our X's small approximation. So we know that 3.5 times 10 to the minus 4 is X squared over 0.150. So we can solve for our X, which is 7.25 times 10 to the minus 3. So my pH is 2.14. So there's my answer. So for a mixture, as long as they're the Kas are different from each other by several orders of magnitude, you can just ignore the weaker one.